Okay, what we're going to do now is we're going to talk about yet another dimension of transforming operators in the observable class, focusing in on the use of the RxJava flatMap concurrency idiom. And we're also going to talk about how to compare and contrast flatMap with map, because those methods, they don't actually appear very similar at first glance, but they look a little similar. They both have mappers, but they behave in quite different ways. So recall that flatMap in RxJava and Project Reactor, for that matter, is often used when the items that are emitted by a stream need to be run in the context of threads or thread pools. And we'll take a look here and see. This is known as the flatMap concurrency idiom. You can read about flatMap concurrency idiom. It's also a nice discussion of the concurrency idiom of flatMap versus something called parallel flowables, which we'll actually get a chance to play around with later in the class as well. So here's a simple example. We're going to go ahead and create an observable stream from a big fraction list. And then for each item in that stream, we're going to go ahead and use flatMap. And it's going to end up at a high level. What we're going to do is we're going to end up multiplying each of those big fractions in that observable stream by a big fraction. And we do that as follows. This is really cool and very interesting and shows off some really interesting idiomatic features of RxJava and, for that matter, Project Reactor. So what we're going to do is we're going to multiply each big fraction in the stream using flatMap to do this. And you can see here we're going to use from callable. And we're going to have the from callable, which is a factory method, go ahead and lazily multiply each big fraction by some constant big fraction. So the key point there is lazily. And we're going to subscribe that computation to run in the computation thread pool. So we're going to arrange to process each big fraction in the computation thread pool, as you can see here. And we'll talk about the computation thread pool in the next part of the lesson. The way to think about this, it's kind of like the common fork join pool, but not quite. Similar idea. It's designed to run compute-bound tasks. And after all the concurrent processing completes, then we're going to use the reduce operator, which we'll also talk about shortly, in order to add up all the results of those multiplications. So that's kind of the big picture view here. And this is very, very common in RxJava if you're using the flatMap concurrency idiom. Something else that we'll talk about later, again, is from callable is lazy. Remember that. From callable is lazy. So now that we've kind of given a quick overview of that particular idiom, which you'll need to know for your assignment, let's compare and contrast map and flatMap. So back in the day, there was this game we had before we had video games back in the 60s called Rock'em Sock'em Robots. And I just learned the other day the names of these two guys. This is the Red Rocker, which I always thought was Sammy Hagar, but apparently it's the Red Robot from Rock'em Sock'em Robots, and the Blue Bomber. So those are the names of the robots. Now you know. So let's compare these two things. Map is an operator that transforms each value in an observable stream that comes in as input into one value. So one value comes in, one value comes out for each value in the stream. And it's typically used for synchronous one-to-one transformations. And the thing to note with map, just like with Java streams, is the number of output elements will be equal to the number of input elements unless something horrible happens, like an exception is thrown that we don't catch. So that's map. And you can see here, kind of the visualization of this using a marble diagram. In contrast, the flatMap operator will transform each value in the observable stream into an arbitrary number, 0 or more. So you can have nothing emitted for each value. You could have one thing emitted for each value. You could have n things or k things or m things emitted for each value. And that is obviously a difference right off the bat between map and flatMap. FlatMap is more commonly intended for asynchronous sort of one-to-n transformations, where something comes in and you're going to make a bunch of things and then you're going to flatten them together. And therefore, as we talked about before, the number of output elements that are emitted by FlatMap may be different from the number of input elements that come in. again, assuming exceptions aren't thrown and so on. FlatMap is very, very, very popular in RxJava. You use it all over the place. And when you look at the programming assignment, you'll see it gets used all over the place. So it's important to understand how flatMap works and how it differs from map. Sometimes when you're getting desperate and you're trying to get your program to work, you'll fiddle around and you'll discover, oh, if I change my map call to a flatMap call, it just works. Don't be surprised if/when that happens. But very common operator used to solve a whole bunch of interesting problems in RxJava. So that's the overview of the next set of transformation or transforming operators in the observable class. So the key transforming operators in the observable class you need to be aware of are map, which is that synchronous kind of one-to-one mapping, and flatMap, which is this more asynchronous one-to-many or one-to-n or whatever kind of mapping. So those are the two things you'll need to be able to understand in order to make sense out of this.